Next is wave function. Wave function is represented by psi. In quantum mechanics, it is postulated that there exists a function, the function determined by the physical situation. The function is called a wave function. Okay, this type of function is called the wave function. So there is take two type of waves. There is a wave function may vary with respect to both the position and of the physical system and time. So there is represented psi of x comma y comma z comma t. This is a wave function, depends on both position and time. That is called as total wave function and is represented by capital psi, like this. Okay, this is a capital psi. The capital psi wave function is depend on both position and time. Okay, so next is the wave function. It is vary with only the position, does not depend upon the time. So it is depend upon the only position, does not depend on time. That is called small wave function represented by psi. So keep in your mind these two wave function are different. So total wave function, that is capital psi, depends on both position and time. The small wave function, that is psi, both are read as psi, but write in differently, like this one and this one, depends on only position. Okay, now take a total wave function, can be represented by the wave equation is this is total wave function. So here the total wave function, here where a is a constant and omega is the angular frequency of the wave function, there is take separately write the position and time dependent part. The total wave function can be written as separating these two part. One is position part and time part. So separately write like this, and this is only depends on the position part. The position is directly write small psi. Okay, e power minus I omega t. So this is wave function. In quantum mechanics, account for the wave-like properties of particle. It is obtained by solving a fundamental equation called Schrödinger equation. To solve the Schrödinger equation, it requires the knowledge of potential energy of the particle and initial condition and boundary conditions. Okay, so next the Schrödinger equation can be divided into two equations, two classification. One is time dependent Schrödinger wave equation, and second one is time independent Schrödinger wave equation. Okay, so this is time. What is time dependent, time independent? So here the wave function is depends on both position and also time. That is called as time dependent equation. This is equation. This equation derivation is not necessary in some point of view. Next, time independent Schrödinger equation is, this is time independent. This means it depends only on the position, does not depend upon the time. Okay, that is called time independent. Okay, so here your exam point of view, here we defined only the time independent Schrödinger equation. This is okay, this is not required your exam point of view. Okay.